All right, now let's look at the order in which code is executed in C++. We have our existing code here, and I'm going to delete the 2 there so that this will actually compile. What I want to do is now add another fake library or 2. Let's say we have our fake custom display, or maybe I'll make it be explicit and say this is like using display library. And this should have its header guard. And inside here, what I'm trying to show you is what your code might look like. So this would be your code, which I have a nice typo in the name here. Let me fix that first. In your code that you write for the display, you're including that U8 x8 lib, but I don't want to have to edit that code to demonstrate a few things. So what we're going to do instead is just say that we're including some display library, some fake display library. And so I'll create that fake display library on top of this. These are horribly named files, but I'm just trying to get the point across here. And so they'll do the job for that. What I asked you to do in your code is to create a class called, let's call it the display class. And inside this class, you'll have something called a constructor, which in C++ looks something like this. And most of ours will also have a setup function and a loop step function. So that's the majority of what each of the classes we write in the class in our course will look like. We'll include some library that helps make our job easier, and we'll basically just wrap that library to have the functionality that we want to simplify using the display library and make our code inside the sketch file just that much easier to use. So here's where we would include our using the display library. Hopefully that's not too many hoops to jump through to show you what I'm trying to show you here. So in your sketch code, you'll often do something like this. You'll create the object that's found inside your using display, or found inside your library. And then inside here, you'll call the setup function. And inside here, you'll call the loop step function. And the first error we're getting here is that these are probably unaccessible, or inaccessible. So to make them accessible, I would have to say, okay, these are all public parts of the class. And jumping back to our sketch, those errors will now be gone. I should mention, I did find some documentation on the Arduino website that when you are creating libraries, you should really favor using something, calling this the begin function. And so maybe later in the semester I'll actually clean up our code to get rid of all of the calls to setup and call them begin. I kind of like the symmetry of calling setup and setup in a step inside of loop. So I also might just leave this. But now let's look back at our using display library code. So let's say that inside display library, there's some class defined called, I don't know, let's call it the display driver object, and I'll just call it driver inside here. The C++ extension is now telling me it has no idea what display driver is. So let's go into this file, the display library file, and create that class. And it probably does, in fact, look something like this, but again, in that class, they probably call it begin. That's more standard Arduino coding style. And I really should set up the header guard. Alright, so we have this functionality, and it has what's called a default constructor. When you have a constructor that looks like this, with no arguments, and it doesn't do anything, that's called a default constructor, meaning if I didn't actually define it, it would be perfectly fine and the code would execute the same. It would just do nothing. And if I have some private member variables, like let's say I have an integer called a, without the default constructor being initialized here, without it being defined here by me, this will get a value, I believe it'll get set to 0 if I remember my C++ correctly. And then if I have code like this where I do in fact define this, it won't get defined. I get to choose what it's initialized to. So for example, I could say a equals 0. Or maybe I have some other better value for the default. Things get more interesting though if I have additional constructors. Let's say I have a second constructor, this one where I pass in an actual value to set a to. So this is called function overloading in C++. I can have the same function defined multiple times, and as long as they have different arguments, C++ will know which one is being called. I could do the same thing here. I could have two different functions for begin, and as long as they take different arguments, C++ can figure out which one I'm trying to call. The confusion comes in often for students who see C++ for the first time is, when do these actually get called? Because C++ hides a lot of those details from you. So what I'm going to do is add some print statements so we know when these are getting called. And yeah, I think that's fine. We'll call display constructor. It's a perfectly fine message to print. I think I'll also call this the default constructor, the no argument constructor. And it's complaining that it doesn't know what the output stream is, which is fair because I've not included it. Let's also put a print statement inside our constructor that has an argument. And we'll call this the oneArg constructor. And I think for completeness sake, we might as well... I think it's pretty clear when begin gets called, because we explicitly call that one. So I'll really just have those two constructors and the print statements associated with them. That should be all we need for this demo file, so I'm going to close that one. And now if we go back to our library, so you can assume that's code we would never touch. That was written by somebody else, some third-party library, and this is us using that third-party library. Now we're going to see when those constructors actually get called. So it's not clear here if I'm actually ever calling a constructor. I've got this defined, but where does this driver object actually get initialized? And so at this stage, let's just compile and run this program and see what happens. So you can see, even though I'd never actually have parentheses where I'm calling that default constructor, it does get called. And I think to prevent myself from having to do Control-C to kill the program each time, I am in fact going to kill the fact that this is a while loop and just leave it there as comments. Well, let's see. What happens when I explicitly want to call the constructor instead of having it implicitly called? I could do something like this. And let's call the one with no arguments. And let's additionally do a print statement. So this is display default constructor. All that looks good. Yeah, I think I can agree with the automatically generated, the Copilot generated code there. Let's go back to the display library. And what did I call that? Display driver. Good. So I will be able to tell this is display and the other one's called display driver. Before I run this, it would be good to try to predict what the output would be. So we come in here to main. We have a init here, and actually this would be a great place to put another print statement. So we'll have the beginning of main here. And I'm not going to put anything for init because I think it's pretty clear when that gets called. It gets called immediately after main. But maybe actually I should go into here and just show you when this gets called. So now a reasonable assumption might be we have our main function called, or sorry, defined. We have main called here. We call init, which we know doesn't do anything. We also have setup. Let me drag the order of these. So in setup, that is where display is initialized. So you might think main is called or printed out, and then display gets created, and so we get the constructor called there, and then setup gets called inside setup from calling that inside main. And then we have no print statements after that. We're really just printing when things are called for the first time, or when they get constructed for the first time. So pause the video here and try to predict what you will see on the output from those print statements. And hopefully you've had a chance to do that. And when I run it, I see that I need to recompile first, because I added that print statement in main after that. And you can see the display driver default constructor gets called, then the display default constructor gets called, and then another display driver default constructor gets called, and then we call main, and then we call setup. So what's happening here is that anything defined in the global scope, so anything outside of a function, so that would be anything defined sort of outside the main function, anything defined outside setup, outside of loop, anything defined outside of this class, or this class. And you can see there's nothing defined outside of the class in here, nothing defined outside of the class in here. But for our sketch, we have a globally defined display. This has to call the constructor whenever this gets created at the global scope. That's probably the first thing that actually happens. Not probably. That's actually what happens right here. Is we are calling the constructor for display. And for display, if you look at its default constructor, you would think it would call display default first, this one. But since we have a display object being default constructed, it first has to default construct any of its members. So the driver, the display driver default constructor gets called first. So this gets called first, and then we go into the code, the body of this constructor, which means display default constructor gets called. So driver, display, and then the default constructor gets called a second time for the same object. So driver is default constructed here, and then we override all of that information and call it again. So you might imagine that if this default constructor was doing a lot of work, we wouldn't necessarily want to call that twice. And that would be a very good observation. So much of the time, this kind of code here would be entirely redundant. We don't actually need to do that. So if I save that, recompile, and rerun it, you'll see that we only call it once at the very beginning, and then we call our constructor on the display object, and we don't have to initialize this again. It only gets initialized once. However, that gets a little trickier when we want to, and so now you're going to have the payoff why I have the second constructor here. That gets a little bit trickier when I want to call something that's not the default no argument constructor. What if I want to pass in an argument to the constructor, for example, the value 44? Now I'm back to calling the default constructor, and then inside of the display constructor, I'm calling the one argument constructor of the display driver. That again is not necessarily what you want to do. It would be nice if we didn't have to call this constructor twice. If we didn't have to call this one, and then override it and call this one. Again, this is really not doing much work here. It's just printing something out and then setting a value, an integer value. But if both of these were doing, 2 or 3 seconds worth of work, or even if they were doing something more catastrophic like writing to a file, and then this is overwriting to the file that second time, you could see why that wouldn't be what you might want in all times. So this is where we get to that neat piece of functionality, neat in quotes. It's a bit of a hack is what it looks like. It is part of the C++ syntax, but it doesn't feel as natural. But if I want to tell the display class to not use the default constructor for driver, the way you do that is you call the constructor in the member initialization list right here. So now I can comment this one out, and this says, okay, before you call this constructor, when you're default constructing, when you're initializing any member variables, this is how I would like you to initialize them. So now we should see that the default constructor for the display driver is never called. Instead, just the one that takes an integer value. And so now we have the one argument constructor being called and just our display constructor being called. Taking that one step further, you've often seen that I can pass in an argument here. So what happens if I want the value of a here to be passed in here? Well, at this point, I'll get a compilation error saying that where I'm calling the default constructor, calling the constructor for display, there's no matching initialization of display. I'm supposed to pass in an integer, but I didn't pass in an integer. So that would be this line of code here that's causing a problem. So here, I might say, here's a value of a, and now I can pass it in here. And again, I can call the one argument constructor, but now I'm calling it with a value that I've specified. One final wrinkle that C++ lets you do, I can delete that, I can delete the a from there, and I can still make this code work without having to duplicate the work here of having two constructors. I can also put a default value here. And I was not expecting an error here. Let's see what this one is. Base of member reference is a function. Perhaps you meant to call it with no arguments. Display. Oh, did I make that change in the wrong place? I did not. Let me pause the video here and see the recording and see what my error is. And I think the problem here is my use of parentheses. Yes. A pretty bizarre error there, but the fact that I left parentheses there meant the C++ compiler, I think, was assuming this was me doing a prototype for a function call. So let's say I had a function called test. I could then define that function somewhere else, like so, and this would be a prototype for the function. Now if this returned a value, it would look something like this. And what you might notice here is with the parentheses, these two lines would look an awful lot alike. type, return type for a function, return type for a function, name of the function, name of the function, calling the function, calling the function. So with those parentheses, the C++ compiler was actually getting confused. It didn't realize I was defining a variable. It thought I was calling a function. And that would be just one of the many joys of the C++ programming language. Alright, so a quick recap of what we've discovered here is that the Arduino main function calls your setup and calls your loop functions. It includes a bunch of default functionality. Here I just put in a init, but you would also find your functions for the analog write function would be in there. Analog read. Digital write and digital read. A number of bits of functionality. The serial object would be defined in here. So this file is going to define all those bits and bobs that make your life easier using the microcontroller instead of having to define them all yourself. And yes, okay. This is really a class object. So in the next video, we'll set aside a lot of this demo code and actually start writing Arduino sketches using the Arduino command line interface.